welcome to TMRM Art YouTube channel. So today we are going to see the previous year question of 2021 organized by IIT Bombay GATE ECE PYQ. Okay, so here only the technical parts, 30 question I have taken. Okay, so on that I am going to revise those questions with concepts, and it will be helpful for you and me both for 2027 exam. Okay, for ECE paper. Hope you will enjoy the video, and let's proceed. And before that, always stay motivated till the exam. Okay, just remember the result declaration date. Okay, that day how you want the result, just fill that and let's start. Okay, question number 26. So here consider the integration close integration sine x by x square into x square plus 4 dx. So where c is a counter clockwise oriented circle defined as mod of x minus I equal to 2, the value of the integral is. So the integral value we need to find out. So here with the residue theorem we can solve this type of problem. Okay, first, what is residue theorem? If fz is analytic inside and on a closed curve C, okay, except a finite number of singularity inside C, then close integration fz dz equal to 2 pi I sum of residues. Okay, so singularity is a point where the function fz fails to be analytic. Okay, that means the function is not defined or become infinite at that point. Okay, so in this residue theorem we can find out the integration using this formula. Okay, you can remember. So here it is given in this question, fx is this one. Okay, so we can write this x square plus 4 in this format. Okay, you can understand, if you multiply these two you will get this. Okay, so here and the poles are we can see this is a pole, because if you give x equal to 0 it will become infinite. Okay, 1 by 0 is infinite, so x equal to 0 is a pole or is a singular point, you can say. So it is having order 2, because here you can see order 2. Okay, and another poles are x equal to 2i and minus 2i. Okay, if you equate these two with 0 you will get this. Okay, then given curve or origin is given this one in the question, you can see here. Okay, so let's say x equal to a plus ib or jb, where a and b are real. Okay, so j equal to this one, so x minus j. Okay, this is given here, so this we can write in this format. Okay, now the mod value is this, mod value will be this. Okay, so set this equal to 2. Okay, this equal to 2, it is given in the question. Okay, so here if we equate, this is the equation of a circle. Okay, in the complex plane, center at 0 and 1, 0 and 1. Okay, so here this is 0 and 1, that means somewhere the 0 0 point is here, but our circle's center is here. Okay, and the radius is 2. Okay, from here to here the radius is 2. Here you can see this is equal to 2 square, so that means radius is 2, with radius 2. So here x equal to minus 2i lies outside the curve, because if you put here x equal to minus 2i, so minus 2i minus I, if you take mod it will become minus 3i, and the mod value will be 3, which is greater than 2. Okay, so this is outside, this point is outside this circle. Okay, so the singular points are only s equal to 0 and s equal to 2i. Okay, the residue at x equal to 0, it will be as order is 2, so here d by dx will come. Okay, from here you can see the formula, general formula. So order represent here n, so here you can put the value of n2, because 0 pole is there, 2 0 pole is there. Here you can see we have seen here. Okay, so the formula will come this. Okay, you can see the x square and below there is x square, this will be eliminated, so only this term will be there. You can apply the formula, you will get this. I think you are understanding this. Okay, and okay, so now the limit, and limit value is x tends to 0, the pole where it is exists, it will tends to that point only. So now derivative, if you do, it will be like this. Okay, I think you know this. Now if you put x equal to 0, it will come this. Now residue at x equal to 2i. Okay, as a x equal to 2i, if you put this, and here then you need to multiply this with the function, then it will be eliminated, and the remaining term here we need to put x equal to 2i, so we will get this one. So here just carefully look, only x equal to minus means x minus 2i, this exists. Okay, means 2i, this here pole is exists only, and the other pole, this minus 2i, is out of the circle, so we are not considering while calculating the residues. Okay, now using the residue theorem, the closed integration value will be 2 pi I into sum of the residue. Okay, 2 pi I into this one we have calculated, and this one. Okay, so here you will get the answer. Now moving on the next question. Okay, so here a box contain the following 3 coins. Okay, a fair coin with head in one face and tail in another face, and one face is head, another face is tail. Okay, tail. So another coin is also there where both the faces are head. Okay, one is head, another is head. Another coin is here where both the faces are tail. Okay, tail. So a coin is picked randomly from the box and tossed. Out of the remaining 2 coins in the box, one coin is picked randomly and tossed. If the first toss results in a head, the probability of getting a head in the second toss. Okay, so first toss it is coming that it is head, then the probability that second toss is also head, that we need to find out here. And there are 3 type of coins. So conditional probability is defined like this. Okay, probability of A by B means B already occurred, then probability of, what is the probability of A? It is defined like this: probability of A intersection B by probability of B, and similarly probability of B by A equal to probability of A intersection B by probability of A. Now application, let event A is defined as A equal to getting head in the first toss. Okay, and event B is defined as getting head in the second toss. So according to the question, we need to find the probability of getting a head in the second toss when already a head has occurred in the first toss. So the probability of getting head in the first toss will be this one. Okay, so already a head occurred, that is A, and the second toss, if we get the head, the probability is B. So probability of B by A we need to find out, that is this one. So probability of A, that means the first toss is head, that will be probability of fair coin is selected and probability of getting head, or the double headed coin is selected and getting head. Okay, so selecting the fair coin is, out of the 3 coin, one we need to select, so it will be 1 by 3, and the getting head, it will be 1 by 2 because one is head, another is tail. And double headed coin is selected, then also probability 1 by 3, and there will be both the side head, so probability is always 1. So now this multiply and addition, you will get 1 by 2. So probability of getting head is 1 by 2. Now finding the probability of getting head in both the tosses. Okay, both the tosses, it will be so first toss, like we are first selecting that fair coin and then getting the head, and then that biased one means both the side it is head and getting head, and next uh, first we are selecting that biased one means both the side it is head and getting the head, and then next time that we are selecting the remaining one. Okay, so one coin we already taken, so only 2 are left, so that's why 1 by 2. So their probability is 1 by 2 because this one is the fair one, this is the biased one, this is the fair one. So first we have just taken this, then we have taken this, so already one is less. Okay, in that combination there are 3 coin, but one, if we take 2 will remain, so the probability of getting that fair coin out of the 2 is 1 by 2, and there if we get the head, the probability is 1 by 2. I think you are understanding this. You can see it again, and you can realize. Okay, so probability of A intersection B equal to 1 by 12 plus 1 by 12 equal to 1 by 6. If we add and calculate this, we will get 1 by 6. Now probability of B by A equal to probability of A intersection B by probability of A. So it will be 1 by 6 by 1 by 2. So it will come this one. A already we got, then this one also we calculated. So this is the answer. This actually we need to find out. So this is matching with this one, option B. Okay, and here the earlier one, this was answer, I think this one. Okay, so answer is 2. Okay, you can check here, the value of the integral is coming, I think answer wrong, so this is the answer actually. Okay, we will proceed. Answer given wrong there. Now question number 28. Okay, the switch in the circuit in the figure is in position P for long time and then move to position Q at time t equal to 0. Okay, at t equal to 0 it is moving from P to Q. So we need to find out dVt by dt at t equal to 0 plus. Okay, so solution is under steady state. When first the concepts we are discussing, under steady state, when a capacitor is present with a DC supply, it behaves as open circuit. Okay, when DC supply we apply, then capacitor will be open circuit. When an inductor is present with DC supply, it behaves as a short circuit. Okay, so at t equal to 0 plus, inductor replaced with current source, that means IL 0 plus equal to IL 0 minus. This is valid actually for inductor, and the inductor does not allow the sudden change of current. Okay, this signifies this. The capacitor is related with the voltage source. Okay, Vc 0 plus equal to Vc 0 minus. The capacitor does not allow the sudden change in voltage. Okay, calculation now we are doing. At t equal to 0 minus, switch is at P position, so the network is in steady state. Okay, here you can see this is the position P. Okay, so at steady state the switch is at P position, means long time it is in that position only, that's why it is in steady state. So the capacitor will be obviously open circuited, means how much it can charge, it is already charged, and inductor also, like it cannot resist more, it is already in the steady state, so it's short circuited. So the inductor current at 0 minus, it will be 20 by 20, means 1 milliampere. So like here I have drawn it again. So capacitor is open circuited and the inductor, this is short circuited, here you can see. Okay, so here if we calculate this one, so this is 20 volt. Okay, 20 volt, so 20 volt by this all resistance, that is also 20, so it is 1 milliampere. So IL 0 plus also it will be 1 milliampere. So now Vc 0 minus, Vc 0 minus, how we can calculate? We can calculate the voltage drop across this resistance. Okay, so it will be 10 volt, because voltage is divided equally in this two resistance. Okay, so here also 10 voltage drop, here also 10 voltage drop. So Vc 0 minus is 10 volt and Vc 0 plus also it will be 10 volt. Now at equal to 0 plus, switch is at Q position. Okay, so here P to Q the switch will come, so this part will be disconnected, only this will be there. Okay, so this part only remaining. Now applying KCL at this point node A, so it will be here the capacitor voltage, it will be there 10 volt. Okay, we have already calculated here. So this 10 by this resistance. Okay, this is the voltage actually in this point, in between these 2 point also, means this 10 volt. So here 10 by 5. Okay, this portion, and this IC is coming here, IC 0 plus, and here also inductor current. Okay, this one, so this will be 0. Then from here we can calculate IC 0 plus, that will be -3. Okay, so IC the capacitor current we can write like this: C dV CT by dt. Okay, so this is equal to -3 milliampere. So at t equal to 0 plus it will be -3 volt per second. Okay, so this only we need to find out. So the answer is -3 volt. So here one thing just I wanted to tell, this is not any technical part, it is something non-technical, and I think your common sense, or you can say somewhat your common sense, like you can see the options here. Here 3 and -3 volt, these are only, these numbers are matching. Okay, so as a examiner point of view, like who is just writing this question, so he can think like this is the answer or this is the answer, so I can give another answer with different sign. So that sometime actually in the mindset like that it works, so we can think like that way, the options. So here -3 volt per second is the answer. Now the next question is, consider the two-port network shown in the figure. Okay, this is a two-port network. So here we need to find out the admittance parameter in Siemens, that is the Y parameter. So Y parameter is these are also called the admittance parameter. The Y parameters for the two-port network are shown as this I1, I2, Y11, Y12, Y21, Y22, V1, V2. So I1 equal to this one. You can multiply these two matrix, you will get this. Okay, so calculation. Now consider the circuit with the nodes specified as V1 and V2. Okay, this is the node 1 and this is the node 2 we are calculating, and this node voltage is V1 only, because this point and this point having same voltage, and with respect to ground, this is always V1 only, and here also same, this point and this point voltage difference is V2 only. So writing the node equation at node 1, here you can see here the nodal we are using. So this I1 is entering, so this is minus, and here one current is coming out, so this is V1 by 1 plus, and another here this current is entering, so we are just writing is -3 V2 plus this here V1 and here V2, so plus V1 minus V2 by 1. Okay, so from here I1 we will get, writing the node equation at node 2. So here also again we are writing the node equation, so I2 is entering, so minus I2, and then V2 minus V1 by 1. Okay, so V2 by 1. Now I2 equal to here minus V1 plus I2, this will come. So Y parameter also like this, like left side I1 it will be there, and right side V1 and V2 terms will be there. So Y parameter will be the coefficients of this V1 V2 is just right here. Okay, here -1, here 2, so you are writing this is the Y parameter. So this is matching with the option A, you can cross check. Okay, now question number 30. So for a N-channel silicon MOSFET with 10 nanometer gate oxide thickness and substrate sensitivity is this. Okay, del Vt by del VBS is found to be 50 millivolt per volt at a substrate voltage VBS equal to 2 volt, where Vt is the threshold voltage of the MOSFET. Assume that VBS very much greater than 2πb, where Q5b is the separation between the Fermi energy level EF. Okay, the intrinsic level EI is the bulk. So parameters are given here: electron charge, vacuum permittivity, relative permittivity of silicon, and relative permittivity of oxide. So the doping concentration of the substrate we need to find out. Now here little concept let's discuss. The threshold value for the transistor is given by Vt equal to Vto plus this gamma into root under VSB plus mod of 2 phi f minus root under 2 phi f. okay, bracket close. So here VBS is the is for the n channel transistor. Okay, so VBS is the substrate voltage actually. Okay, substrate voltage, and here gamma is the fabrication parameter or body effect coefficient, you can see, and this VBS is the substrate voltage, and the VTO is the threshold voltage when substrate voltage is 0. Okay, this is the threshold voltage when substrate voltage is 0, and it is for n channel transistor. So given that the substrate sensitivity is this one, okay, so how much that threshold voltage can change with respect to that substrate voltage change. So here we can do the derivative with respect to V or BS. Okay, SB or BS, you can BS is for the n channel and this is for the p channel. So in our case it is n channel, so it will be BS. Okay, so if we do the derivative here, it will come like this. Okay, here 0 plus it is written. Okay, so now in the question it is given that phi b equal to phi f. Okay, that Fermi energy level difference actually this is. So here gamma, it will gamma formula also we need to remember. This is equal to root under 2q na epsilon si by cux. Okay, 2q na epsilon si by cux. Now here we can put it. Okay, so this will become this gamma into, okay, so here again we have written this. So now we are putting this thing here. Okay, so it will become this, you can see, and cux value just we have put it this because this is the capacitance formula, epsilon x by 2x oxide capacitance. So into this part is there. Okay, here we have written. Now that del Vt by del Vbs, it is this one. Okay, and this half of that Vbs to the power minus half, because in the question it is mentioned that phi bs is very much greater than this phi b. Okay, that is q phi b. Okay, or 2 phi b in the formula, 2 phi b on 5 or phi b is there, so it is very much greater than, so this will only remain. Now in the left side we are just keeping this and all the things in the right side. Okay, so here we are squaring both the sides. Now this will come like this. Now na value will come this one. Now all the values we know here. Okay, here epsilon ox will be epsilon ox into epsilon 0. Okay, here epsilon ox is given 4, so 4 into this epsilon 0 value will be there, this one. Okay, 4 into that, and epsilon si value similarly we can put from the question, and tux also given in nanometer, but we can convert into centimeter. Also epsilon 0 given in this, we can convert into per centimeter. Okay, then we can calculate our answer, because in the answer all the things are given in the centimeter. Okay, doping concentration, this units are very crucial things, so we need to take care. So option A will be the right answer, you can calculate it. I'm not yeah, continuing this. So question number 31, the propagation delay of XOR gate and AND gate and multiplexer marks in the circuit shown in the figure are 4 nanosecond, 2 nanosecond, 1 nanosecond respectively. Okay, so here these are the inputs are there. Okay, here is 1 marks, here is 1 marks, these are the AND gates and this is the XOR gate. So we need to find out the maximum propagation delay of the circuit. Now in the given question both marks select line is T. Okay, this T is the select line for both the marks. For input T, there is only two values possible, T equal to 0 or T equal to 1. Okay, now for T equal to 0, this 0, this input will be selected for both the marks. Okay, because T0 only going to both the marks, and at T equal to 0 for marks 1, this marks 1, XOR gate output will propagate to next stage. Okay, this XOR gate output will come to here at for T equal to 0, and for this mux, for t equal to 0, this AND gate output will come to this output. Okay, so propagation delay is actually the this output means where we are getting the output, that delay we need to get actually, because here the maximum propagation delay of the circuit actually it is told. So that is calculated with respect to output, means when we are giving the input and after how much time we are taking the output. So this line only we need to consider, because here only we are getting the output for t equal to 0, because for t equal to 0 here, if even if the output will come, but this input line is not selected because here t equal to 0. Okay, you are getting, I think, this input line not selected. So even if this input line selected, it will not go to the output, so only this line we are selecting. So the propagation delay is one AND gate and another is 1 mux. So AND gate delay is 2 nanosecond and mux delay is 1 nanosecond, so that is 3 nanosecond. Now case 2 is at t equal to 1, this line will be selected. Okay, this input line will be selected, so here it will come, and now from here it will go to the output. So then the output y, then AND gate, here in this path one AND gate is there, then mux is there, another AND gate is, again AND gate is there, then another mux is there. So total delay is 2 plus 1 plus 2 plus 1, that is 6 nanosecond. Okay, I think you are understanding. So the maximum propagation delay is 6 nanosecond. So maximum is out of these two 6 nanosecond. So here option is C. Now moving to the next question, number 33. These are microprocessor question. We are skipping, currently not part of GATE ECE syllabus. Okay, so now question number 33. The electrical system shown in the figure converts into source current IS to the output voltage. Okay, this it is converting to the output voltage. Current ILT in the inductor and voltage VCT across the capacitor are taken in the state variables. Okay, both assumed to be initially equal to 0, that is IL0 equal to 0, VC0 equal to 0. The system is completely state controllable or completely observable or not observable, not controllable, these things we need to check. So first we need to understand this, like for controllability and observability, following condition must be satisfied. Okay, so controllability is like QC equal to BAB. Okay, here if this mod of QC equal to 0, then the system is uncontrollable. Here B and A, these are one matrix. Later on we will see what is B and A actually. So if this matrix determinant value is 0, then it cannot be controllable. This is uncontrollable. And if it is not equal to 0, that means it is controllable. Similarly, observable is, this is a matrix like C is the first row and second row it is CA. Okay, multiplication of these two matrix. Now here this matrix mod value, if it is 0, then it is unobservable. If it is not equal to 0, then the system is observable. Now the application. Let us first develop the state model of the given circuit. Okay, we need to find out the state model, and in the question it is given that state variables are these two. Okay, we need to keep in mind. Let VLT be the voltage across the inductor and VRT be the voltage across the resistor 1 ohm. Okay, VLT is the voltage, VLT means here. Okay, here VLT is the voltage across the inductor and VRT be the voltage across the resistance here. So VRT equal to VLT, this is VLT. Okay, VLT, and this is VRT. So both are same, and it will be that inductor voltage equation, that is L dilt by dt. Okay, so with L equal to 1 Henry, so here voltage equation will be this, and this current, total current, it will be here it is going like this. Okay, so here also you can see it is going the total current, so it will be sum of this two branch current. So it is ILT plus I of R means IRT, resistance current. So IRT, it will be the voltage across it by the resistance, okay, and that is equal to VLT. So IST, we can write this ILT plus this VLT. So VLT, we can write this one, okay, L dilt by dt, and L is 1, that's why dilt by dt. So everything we need to represent in terms of IL and that VC, because those are the state variable. Okay, so now dilt by dt, this need to be in the left side, and this minus IL, it will be in the right side, and IST, it will be right side. Let ICT be the current through the capacitor. Okay, ICT is the current through the capacitor. So the capacitor current formula is this, C dVct by dt. So C equal to 1 farad. So ICT, it will become this. So again ICT will be so ICT will be this current is IST, okay, IST minus this resistance current, because the current will be divided here, this two part. So if we minus this current from this current, you will get this current, okay. So same thing it is done, like IST minus VOT by 1 ohm. So and VOT and VCT both are same, because here this is the output terminal, and this same voltage actually, this and this, okay. So here we can write it, okay, ICT, this dVct by dt equal to IST minus VOT is VCT, so VCT by 1. We need to write everything in terms of VCT, and that here it is IL. So and left side we need to keep this dVct by dt equal to this one, okay. Now these are the two equations. Here first equations, here minus ILT, then we are adding, means writing just this to understand, 0 into VCT plus IST, and the second equation here we are writing 0 into ILT plus these terms, okay. This 0 actually not correct. I'm just removing this. Here minus sign is there, okay. Now okay, so we can write it here like IL and VC. So here coefficient is minus 1, and this coefficient is 0, and this coefficient is 0, and this coefficient is minus 1, and here IS coefficient is 1 and 1, okay. So VO and so VO, it is 0 1, and IL VC, because VO equal to VC only, okay. We have seen here this VO and this VC is same, this is same actually voltage drop. So if you multiply these two matrix, you will get VC only. So here A matrix is this one, okay. So earlier I have told that you will understand what is A later, and this is B matrix, and this one is C matrix. Now for controllability of the matrix, we need to see this matrix, okay. B into AB, it will be like this, and mod of QC equal to 0. The system is not controllable, okay, as the mod value is 0, this is not controllable. And the observability matrix, we can see C, here it is C, and C into A, if we multiply, then this matrix will come, okay, from this. If we take the mod, it is also 0, then we can conclude the system is not observable also. So here neither controllable, not observable, okay. I think you understand the concepts. Thank you. And then next question, a digital transmission system uses a 7,4 systematic linear Hamming code for transmitting data over noisy channel. If 3 of the message code word pairs in this code MI/CI, where CI is the code word corresponding to the ith message, MI are the known to be 110001100111001110 and 0110100110. So when then which of the following is a valid code word in this code? Okay, this we need to find out. So 7,4 Hamming code, meaning 7 bit in each code word. Okay, each code word there will be 7 bits, and out of them 4 bits are message bits and 3 bits are parity bits, and it is a systematic. Okay, so the message bits are included directly in the code word. So parity bit means extra bits added to the data to detect the errors during transmission. Okay, now again we have written these things like code word. We can write like this: first message bits, then parity bits will be there. Okay, and this the main parts just I am trying to revise here. Okay, these are the standard Hamming code like C1, C2, C3, C4, C5, C6, C7. So first two it is like parity bit, then one message bit, then one parity bit, then one message bit, one message bit, then one parity bit. The standard Hamming code, but this is asymmetric Hamming code. If this format would given in the question, then this P into C1, P C2, P C3 equal to 0. Okay, we would check this parity bits. Okay, means PC1, PC2, PC3 should be 0. If all 0, then it would be a valid 1. Okay, not here P in. Okay, now our application here it is, but in our case, in our question, they did not give us the standard way. Okay, they give us systematic Hamming code. Okay, that is in this format. First there are these message bits, then these parity bits. Okay, now here we know that the Hamming code is a linear code as well. Okay, for linear code all the 0 would be a valid code. Okay, and D minimum will be W minimum, and another is C3 equal to C1 XOR C2. If you do XOR of any two code, you will get a valid code. Okay, so if you XOR any two such code, you will get another valid code. That might not be C3, that can be C5, C4, like that, anything. So observe when P0, P1, P2 are 1 and write their combination. So here this part actually I am telling at the last. First let's understand this. So given k equal to 4. Okay, so code words possible is 16. K equal to 4 means 4 parity bits are there, so code word possible is 16, but out of them only one will be valid. Okay, so out of them only 7 is there, so out of them only one will be valid. Means in this answer they are telling out of this 4 answer only one will be valid. Okay, so data word and code word it is there. Okay, now here we are doing this C4, we are getting using C1 and C2 XOR, we are getting this. So if you do this C2 C3 or C1 C3, the last bit will come always 0, because 0 XOR 0 is always 0, and again 0 XOR 0, that will be also 0. Okay, so using these 3 code word, will you be able to find 16 code word? Answer is no, because last bit is always 0 here. So I can check only option B and D using this linear code concept after doing XOR. The last bit is always, as the last bit is always coming 0. Okay, we cannot determine the code word ending with 1. Okay, we cannot determine the code word ending with 1 by doing XOR, because we will never find that code word ending with 1, because the existing code words having the last bits 0, so we cannot find doing XOR. So we can check only this and this doing this XOR operation. So we can determine this 16 minus 8 code words. So we can determine the below code word doing this XOR operation. So here we have performed different XOR operation like C1, C2, C2, C3, C3, C1 or C4, C2, like that. We have done many things, and just the unique one we have noted down. Okay. So here that 8 combination we found for linear code. Now for linear code, all 0 code word will always be a valid code word. Okay, all 0 code word also a valid code word. For similarly Hamming code also, all 0 code word is will always be a valid code word. Okay, this is like we can remember. And also for Hamming code, all one code word will always be a valid code word. It's not applicable for always, but most of the cases in general it is applicable if not mentioned in the question explicitly. Okay. Now this is a very important point actually, valid for event parity, and by default it will be always event parity only. Now this all one code word is like this. Okay, like this. So it is a valid one. So if we do C3 XOR this, suppose this is C9, then we will get something where it is ending with 1. Well, suppose this is C3 and then this is a C9. So if you do XOR, you will get this. Okay, but this is not our answer, because here you can see option A for 1001 110 is the message, but here what we are getting 1001 011 we are getting, but in the question it is given 110. So this option is invalid. Now again this with this code word, if we exert this C7 here, okay, then we will get this one, and this is matching with option C. So this is the solution. Now NPTEL has given another solution, that is like they just seen the pattern. So in the question already given this thing. So here the first P0 they have written like this, like D0 this. Okay, these are the parity bits. Okay, these are the data bits. I have told, I think somewhere wrong. This first 3 is the parity bits and this is the message bit. Okay, now so they have given in NPTEL like this. So D0 XOR D1 and then XOR D3. So similarly like this they have given, but some video solutions they have given like this, but this is applicable only for C1 to C8 code word, not valid for this one. If you cross check these things with this, okay, so it will not match. Okay, but this is matching with this, so this should be the, this also can be there, can be a way of solution. Okay, so we can check the option the first option. So here P0 is this D0 XOR D1 XOR D3. So 1 XOR 0, that is 1, and 1 XOR 0 again 1. So similarly here P1 also, this is D1. Okay, D1 XOR D2, 0 XOR 1 1, and D2 XOR D3. This 2 XOR this is also 1. Okay, so similarly P2 will check. So this is coming 1 1 0, but here 1 0 1 is there, so this is not correct. So like that, if you check all the option 3 is coming the answer. Now moving on the next question. Okay, question number 35. The impedance matching network shown in the figure is to match a lossless line having characteristic impedance Z0 equal to 50 ohm with a load impedance ZL. A quarter wave line having a characteristic impedance Z1 equal to 75 ohm is connected to ZL. Two stubs having characteristic impedance, here it is given, one is open circuited, one is short circuited with different lengths. Okay, so here this is PQ terminal, this is RS terminal. The impedance matching is achieved when the real part ZL is. Okay, when impedance matching is happening, then the real part of ZL will be what? That we need to find out. So given that lossless line characteristic impedance Z0 is this one. So open circuit stub characteristic impedance is 75 ohm. Now short circuit stub characteristic impedance is this one. Sorry, this one short circuited, this is open circuited. So method one is like the given arrangement of the transmission line is shown below, same drawn. Then for this ZL line 1, okay, this is line 1. So this is open circuited, so that means the ZL will be for this line, here it is infinite, and for this line 3, okay, line 3 it is short circuited here, so it is 0. Now input impedance of lambda by 2 long line, this is actually length is 0.5 lambdas, that means lambda by 2. So Z in L equal to lambda by 2 line equal to this line 1 it is equal to infinite open circuited. Thus total impedance at the terminal this QR is, okay, this is Q and R, Q and R. So total impedance of this line is Q and R, here it is written like this QR. Okay, you can see here also QR, but in the question here they represent RS, so don't see here as of now, as of see my solution only. Okay, I'm following this. So QR, okay, so this terminal here it will be actually this one parallel with this one. Okay, so ZL infinite this one, so one is very high, so small one will be answer. You can do the parallel like how you do the equivalent resistance, you will get this. Okay, so now arrangement of the transmission line becomes only this part is there, so and this part is there. Thus the input impedance of the line 2, so it is ZD equal to this formula is there, so if you calculate you will get to this. Now input impedance of the line 3, okay, input impedance of the line 3, this is the line 3 is we have calculated here. Okay, this is Z0 square by ZL, so it will come, as it is short circuit it is 0, so it will come infinite. So thus the total impedance at the terminal is, okay, this line 2 parallel line 3 with this with respect to this point, this and this is parallel, so this parallel with infinite, so it will come this only. So this big term will not come output, small term will come the output in case of parallel. So now transmission line arrangement becomes only this. Okay, hence ZPS work as a load for main transmission line. So this is the final load that works for the transmission line. For matching of main transmission line with load ZPS equal to 0. Now 75 square by ZL here equal to 50 for the matching actually the load, so load matching. Okay, this will be same as the characteristic impedance. So if we equate, we can get ZL equal to this. Now another method is Zn equal to at lambda by 2 it is infinite. Okay, and for the third line also, this is the third line, this is the first line. So for third line, so third line we already got it, it is infinite. So input impedance of both line 1 and line 3 are infinite. So open circuited, so it does not make any effect on the main transmission line. So given transmission line configuration becomes as like this only. Okay, thus the input impedance at the terminal PS, okay, here it is only Z square by ZL, it is 75 square by ZL. okay, because here it is z0 is 75. Okay, here already it is given also. Okay, 75 square by z0. So z in PS work as a load for the main transmission line. So arrangement of the transmission line becomes this one. So here we are getting if we calculate this is the first option. Okay, now moving on the next question. These are the NAT type. Okay, now a real 2 cross 2 non-singular matrix A, the repeated eigenvalue is given like this. So where x is a real positive number, the value of x here x is a real positive number, so value of x we need to find out. Okay, this is a non-singular matrix and repeated eigenvalues is there. So non-singular matrix means it is a matrix whose determinant not equal to 0. Okay, determinant value will not be 0, then it will be a non-singular. If it is 0, then it is a singular matrix. You can relate with that singular point in case of that residue theorem. Okay, so if it is non-singular, then only it is not equal to 0. If A is any square matrix of order n, just for remember I have told this is singular things. Now for if A is only square matrix of order n, we can derive from the matrix, okay, this A minus lambda I. So where I is nth order unit matrix, the determinant of the matrix equated to 0. So mod of A minus lambda equal to 0 is called the characteristic equation of A. This is the characteristic equation and the root of the characteristic equation is called eigenvalues. Okay, the roots of the characteristic and or the characteristic root of the matrix, okay, or the latent roots, it can be said for the roots of the characteristic equation. Okay, sum of the eigenvalues is equal to the trace of the matrix. The product of the eigenvalues of the matrix A is equal to the determinant of the matrix A. Okay, now this is the matrix. So find the eigenvalues. Mod of this now this mod value equal to 0. Okay, to find the eigenvalues we need to write the characteristic equation. So here characteristic equation will always be 0, but the matrix determinant may be 0, may not be 0. Here it is not 0 because it is a non-singular matrix already mentioned in the question. So characteristic equation, here we are getting these roots are repeated already told, so in the question, so we can directly write b square minus 4ac equal to 0. So from here if we just compare, this is b, this is okay, this is b, and this I think need not to write. Okay, 4 x, okay, sorry, it's correct. Okay, so this is c, this is b, this is b, and this one is a. So now if we write here, so we'll calculate and we'll get the x value, and x equal to minus 2 is not possible, okay, because x is a real positive number, it is already mentioned, so it will be 10. Now the next question. For a vector field this in the cylindrical coordinate system rho phi z with unit vectors, this one, the net flux of d leaving the closed surface of the cylinder rho is, okay, net flux leaving that closed surface cylinder we need to find out. Gauss's law said that it states that the flux leaving any closed surface is equal to the charge enclosed by the surface. Okay, phi equal to this closed integration d vector dot ds vector. The divergence theorem states that the surface integration can be converted into a volume integral. Okay, so this closed integration d vector dot ds vector equal to integration del dot d vector dv. Okay, divergence is in cylindrical form for the given vector is del dot d vector equal to 1 by rho del by del rho rho d rho plus 1 by rho del by del phi d phi plus del by del z dz. Now the calculation is given. A given vector field is d equal to rho cos square phi a rho plus z square sin phi. It is given. Now from the given vector dz is 0. Okay, rho phi and z term should be there, but this is 0. So okay, here you can see this is rho phi. This two term only there. Okay, this should be a phi term. Okay, so there is no az term is here. Okay, az term is not there. So del dot d vector, it is 1 by rho and del by del rho, and another rho will be multiplied here. Okay, so rho square cos phi plus 1 by rho del by del phi, here z square sin square phi, here 0. Now del dot d vector equal to this 2 cos square phi. Okay, and if we do the derivative here, we'll get 2. Okay, this 2 rho and the rho will be eliminated, so 2 cos square phi plus z square by rho, z square by rho, and this 2 will come to here sin theta, then sin theta's derivative cos theta. So now derivative part, if we write and the limit, just we need to place limits already mentioned, rho 0 to 3 and this z equal to 0 to 2. Okay, 0 to 3 and rho here it is 0. Okay, so 0 to 3 and phi always 0 to 2 pi. Now if we do this integration, at the end we will get this. Okay, so flux living through the surface is this one. Here one formula we can remember, cos 2 theta equal to 2 cos square theta minus 1. Next, in the circuit shown in the figure, the switch is closed at time t equal to 0 while the capacitor is initially charged to minus 5 volt. So Vc 0 equal to minus 5 volt, the time after which the voltage across the capacitor becomes 0. So after how much time voltage across the capacitor becomes 0, we need to find out. Voltage across the capacitor formula is Vc t equal to Vc infinite plus Vc 0 plus minus Vc infinite e to the power minus t by tau. So here already given, initially it is minus 5 volt across the capacitor. So at t equal to infinite, capacitor act as open circuit, as we know, so it will be open circuited. Now applying KCL at this node, okay, you can relate, only this is open circuited, other and t equal to 0 the switch is closed, so this at t equal to infinite, this is the circuit. Now at if we do the nodal, it is coming like this. Okay, here capacitor voltage is this, so here one current will flow, here one current, and here is another current. So here from here Vc infinite we will get. So time constant equal to R equivalent into C. To find this R equivalent, or that equivalent resistance of the circuit, from this terminal we added a voltage and a reference current. So applying KCL at this same node again, I equal to here I will come, and then this current, and this current. So from here another is this VR is 0, because VR is defined here plus here minus, so we are calculating this like this, 0 minus this node voltage, that is V only. Okay, from here to here, all here V only, so 0 minus V by this into this voltage, this resistance. So here we will get, now we are putting this here, so I will be all this term, because V and I in this format we need to bring all the things in this format, because then at the end we can do V by I to find out this resistance. So equivalent resistance is this one, this RTH also. So tau equal to R equivalent into C. Okay, so VCT is Vc infinite into this formula, just put the values. So Vc infinite value is this one, already we got, and then 0 plus value means initial value is this, and the final value again, then to the power minus t by this tau. Now let vct is 0 at t equal to t1. So it is left side is 0 and here t equal to t1. Now using this ln and all, we will get this time is this. So this is nat. Next, the exponential Fourier series representation of a continuous time periodic signal xt is defined as xt equal to this, where omega naught is the fundamental angular frequency of xt and coefficients of the series are ak. The following information is given about xt and ak. Xt is a real and even having a fundamental period of 6. Okay, fundamental period is 6. The average value of xt is 2. Okay, average value is 2 and fundamental period here it is 6. Xt equal to k 1 2 3 0 k greater than 3. Okay, it is given. So average power of the signal we need to find out. Now here concept, let's discuss. The exponential Fourier series of a function gt is represented as gt equal to this summation of n equal to minus infinite to infinite cn e to the power jn omega naught t, where cn is the exponential coefficient and it is defined by cn equal to 1 by t in the time period integration 0 to capital T, the time period gt e to the power minus j n omega naught t. So okay, this is the coefficient term, and Parseval theorem is, this tells that the total power in a periodic signal is equal to the sum of the squared amplitude of each harmonic. Okay, sum of the squared amplitude of each harmonic is the total power of the periodic signal. So that is 1 by capital T integration 0 to capital T mod of xt square dt, and that is equal to summation of n equal to minus infinite to infinite mod of cns square. And harmonic means a periodic signal like a square wave or triangular wave can be written as a sum of sine and cosine waves. Okay, the lower frequency is the fundamental frequency, that is f naught, and the higher integer multiples are the harmonics. Okay, the first harmonics is f1. Okay, and the second harmonics is 2 into f naught, like that, so on. Now another important note is Fourier series we take for periodic signal. Okay, Fourier transform we take for Fourier series actually we have taken for periodic signal, and Fourier transform we take for aperiodic signal. Okay, this is aperiodic, and Fourier series is a sampled version of Fourier transform. Okay, Fourier transform formula is this one: x of f equal to integration minus infinite to infinite x of t e to the power minus j 2 pi ft dt. So xt equal to integration minus infinite to infinite x of f e to the power e to the power j 2 pi ft df. Okay, in case in frequency domain this is minus, and this is the time domain formula. And in case of this Fourier series, always you will see one time period is taken, because the same thing is repeating actually everywhere, because it is only for the periodic signal. Okay, now calculation, the calculation is, the given signal is defined as xt equal to summation k equal to minus infinite to infinite ak e to the power j k omega naught t, where ak is the Fourier series coefficient. Okay, ak is the Fourier series coefficient given that the xt is a real and even. So this implies that the spectrum also real and even, and ak is also given. So ak we have drawn here. Okay, this is the main value 2, and other terms also there, 1 2 3 it is k, so 1 it is 1, 2 it is 2, 3 it is 3. Okay, and greater than 3 it is 0, or less than 3 it is 0. So average power is 1 by capital T integration 0 to capital T mod of xt square dt. So that is summation of this coefficient's magnitude square only from minus 3 to 3 for value k. So you can see here and calculate this. 3 square 9, 2 square 4, 1 square 1, 2 square 4, 1 square 1, 2 square 4, 3 square 9. So it will come 32. This is the answer. Now next question. For a unit step input UN, a discrete time LTI system produces an output signal. This let Yn be the output of the system for an input. This the value of Y0. Convolution is the sliding of one signal over the folded and shifted version of the other signal. The below figure represents the structures in the continuous and discrete domain. Okay, this is continuous domain ht yt. So yt equal to integration minus infinite to infinite x tau h of t minus tau d tau, and yn equal to summation of k equal to minus infinite to infinite x of k h of n minus k. Cascaded signals are convoluted to given the output. Okay, convolution in one domain is the multiplication in another domain. Convolution of signal with del function, it will be like this: xt convolution with del t minus t naught x of t minus t naught. Now given input is u of n and the output for un is 2 of del of n plus 1 plus del of n plus del of n minus 1. This is the input. Now converting this into the frequency domain. Okay, input is this is the output actually, and this input is un. So even if we convert in z domain, it will be z by z minus 1, and yz it will be this 2z 1 and z to the power minus 1. So h of z equal to yz by xz. So this is this by this. So it will be x z minus 1 into this part, and z I am just dividing it, so it will come this. Next h of z is this, so hn will come this. Okay, inverse just transform. Now the other input signal applied to the same signal. So yn equal to xn star h of n. So yn equal to xn, this convolution with this same transfer function. Okay, now here the property we are using this one. Okay, so we will get this thing, and now another new input is given, this 1 by 2 to the power n even. So in place of n, just to be putting here n plus 1, here n minus 2. So now y0 we need to find out. So again in place of n we are putting 0. So we will get this even magnitude is 1 only. So this 0 is the answer. Now consider the signals xn equal to this, yn equal to this. So un is the unit step signal. Let x e to the power j omega and y e to the power j omega be the discrete time Fourier transform of xn and yn respectively. The value of the integral, this we need to find out. So xn star yn, this convolution of Fourier transform, it will be x e to the power j omega, y e to the power j omega. Now zn, it will be xn convolution yn, then z e to the power j omega, it will be this one. So also using the central ordinate theorem, that means it states that the value of the autocorrelation function at 0 lag, that means tau equal to 0, is equal to the total energy of the signal. So z equal to 0, that is equal to 1 by 2 pi integration 0 to 2 pi z e to the power j omega d omega. So 1 by 2 pi integration 0 to 2 pi x e to the power j omega into y e to the power j omega d omega. So the application is here, xn equal to this, yn equal to this. So and given this one okay, the value of the integral, this one we need to actually find out. So and this is same as this z naught only. Okay, now using the reversal property, time reversal property, y of minus n equal to y of e to the power minus j omega. Hence z n equal to x of n star y of minus n. So Zn equal to this 2 to the power n minus 1 u of minus n plus 2 star 2 to the power n plus 2 u of minus n plus 1. Okay, here we are putting n equal to k, and here we are putting n equal to k, we will get this, and here we are putting n equal to n minus k, and the limit is k equal to minus infinite to infinite. Convolution we are just performing, and these inputs are already given in the questions. Okay, so summation k equal to minus infinite to 2 to the power k minus 1 into 2 to the power here n minus k plus 2, and this term will be there. Okay, so if you calculate this okay, n equal to 0 we need to put at the end. So and from k equal to minus 1 to 2 means 4 times we need to add 2, so it will come 8. Okay, so it will come 8, and this is the thing. So this is the answer only. Now silicon a silicon p-n junction is shown in the figure. The doping in the p region is this one, and doping in the n region is this one. The parameter given are built-in voltage is electron charge, their vacuum permittivity is there, relative permittivity is there. So charge equation in a diode is given as this one: Wn Nd equal to Wp Na. Also the depletion width is given by the formula root under 2 epsilon by q into 1 by Na plus 1 by Nd into Vbi plus Vrb. Calculation. So here Na Nd is given. Na, now here in case of complete depletion, here the complete depletion width in the p side and inside, and Na and Nd is there. Okay, Na and Nd is the doping concentration of that acceptor and donor. So it will be 2 only, because Na and Nd value we have in the question. If we put the value, we will get 2. Now depletion with this sum, if we do, then we will get this one. Okay, because xp is 0.4, and then and xn is 0.2 only, because this whole n part will be depleted. Okay, though this whole portion only it will be depleted, though here this concentration is high, but as the length is very less, this will be totally depleted fast, because any one of the two region which is like depleting fast. Okay, so up to that, how much reverse bias actually needed, so that we need to calculate. So n is depleting fast, and the length is 0.2, the total length. So the total depletion width is this 4 plus 0 means 0.4 plus 0.2 only, and we need to convert it in semi. Now the depletion width is this, and the formula just we need to keep all the things, put all the things, and Vbi plus Vrb. Here you will get Vrb value, Vbi also given. So this is the answer. Thank you for listening me. I am continuing the remaining one in a separate video. Till that, please stay tuned. I think I can make the full 2021 PYQ in 4 or 5 section to revise properly. Thank you for listening.